Good day everyone, welcome, and today we will be discussing more questions on angle of elevation and depression. We'll be treating questions with slightly harder difficulty. Our very first question states that two observers P and Q 15 meters apart observes a kite in the same vertical plane and from the same side of the kite. The angle of elevation of the kite from P and Q are 35 degree and 45 degree. Find the height of the kite to the nearest meter. Now our very first step is to represent our question in a diagrammatical form, and when we do that we get the diagram as shown on the screen with the different values already imputed. Now we can see that we have two triangles, or basically we have three triangles. We have a triangle KQRO, another triangle ROPK, and another triangle ROQK. So we'll be referencing the triangle we are using for our calculation. Now in triangle ROPK, tan 35 will be equals to H over S. So cross multiplying, H should be equals to S 35. We are going to be making this our equation 1. Also in triangle ROQK, tan 45 degree will be equals to H divided by S minus 15. Cross multiplying, H should be equals to tan 45 in bracket S minus 15. Now we have two different values for H, which is our equation 1 and our equation 2. So we can equate both of them together. So equating both value of H together, it becomes S tan 35 is equals to tan 35 in bracket S minus 15. And simplifying, as you're looking for our tangent, it becomes 0.7002S is equals to S minus 15. Rearranging and collecting items, 15 will be equals to S minus 0.7002 S, which makes 15 to be equal to 0.3 S, and dividing both sides by 0.3 we get S to be equal to 50 meter. Now to get the value of H, we are going to be substituting S into equation 1. So equation 1 becomes H is equal to 50 tan 35, which is equals to 35 meter. We have another question from 1999 that states that in the diagram a ladder TF 10 meter long is placed against a wall at an angle of 70 degree to the horizontal. A. How high up the wall correct to the nearest meter does the ladder reach? B. If the foot F of the ladder is put from the wall to F1 by 1 meter, Roman figure I, how far correct to two significant figure does the top slide down the wall to T1? Roman figure II, calculate correct to the nearest degree angle QF1 T1. Now for our solution, to get the value of TQ, we are going to be using triangle QFT. Now in triangle QFT, sin 70 is equals to TQ divided by TF, which will be equals to TQ divided by 10 because TF is 10. Now cross multiplying, TQ will be equals to 10 sin 70, which will be equals to 9.397, and approximately to the nearest meter it will be equals to 9. So the value of TQ is 9 meters to the nearest meter. Now for normal figure BI, or question BI rather, we are looking for T1. This is the distance that is required for us to look for, and we know that T1 F1 will be equals to TF, which will also be equals to 10 meter because they are both the length of the ladder and it didn't change. And QF1 can be known if we know the value of QF. Now we're trying to look for the parameter of our triangle QFT, that's QF1T rather. Now QF1 can be known if we know the value of QF, as I have said earlier. So in triangle QFT, cos 70 is equals to QF divided by TF, which is equals to QF over 10. Thus QF will be equals to 10 cos 70, which is equals to 3.42 meter, and QF1 will be equals to 3.42 plus 1 because the ladder was slide 1 meter, so it will be equals to 4.42, which is equals to 4.4 to 1 decimal place. We get a resulting triangle as shown on our screen. So let this be our figure 2. Now for figure 2, using Pythagoras theorem, T1F1 square will be equals to QF1 square plus QT1 square. we should make qt1 square to be equals to 10 square minus 4.4 square, which should be equals to 100 minus 19.36, which is equals to 80.64. So qt1 will be equals to the square root of 80.64, which should be equals to 8.98, and t1 will be equals to tq minus qt1, so it will be equals to 9.397 minus 8.89, which should be equals to 0.417, approximately to two significant figure to be equals to 0.42. Now for our bii from figure 2, our theta will be equals to angle qf1 t1. Now using our trigonometric ratio, cos theta will be equals to 4.4 divided by 10, dividing cos theta will be equals to 0.44, making theta to be equals to arc cos 0.44, which is equals to 63.9 degree and equals to 64 degree to the nearest degree. Our final question is from 1991, and it states that from a horizontal distance of 8.5 km, a pilot observes that the angle of depression of the top and base of control towers are 30 degree and 33 degree respectively. Calculate correct to three significant figure. Normal figure 1, the shortest distance between the pilot and the base of the control tower, and normal figure 2, the height of the control tower. Now we presented this in a diagram. We get the diagram as shown on the screen. Now for the very first part of our question, in triangle PTRO, the shortest distance is PT. So cos 33 will be equals to ROT divided by PT, making cos 33 to be equals to 8.5 divided by PT, and cross multiplying PT cos 33 will be equals to 8.5. Dividing both sides by cos 33, PT will be equals to 8.5 divided by cos 33, which will be equals to 10.14 kilometer. Also equals to 10.1 kilometer to three significant figure. For Roman figure 2, using our diagram as reference points, the control tower height ST will be equals to Q arrow. So therefore Q arrow will be equals to P arrow minus PQ. Now P arrow is in triangle PROT, while PQ is in triangle PSQ. So in triangle PTRO, tan 33 degrees equals to P arrow divided by ROT, cross multiplying P arrow will be ROT tan 33 degree, which will be equals to 8.5 tan 33, which is equals to 5.520 kilometer. Also in triangle PSQ, tan 30 degree will be equals to PQ divided by QS. So PQ will be equals to QS tan 30 degree when we cross multiply. Now recall that QS is equals to ROT. So PQ will be equals to 8.5 tan 30 degree, which is equals to 4.908 kilometer. Now substituting into ST minus Q arrow, it will be equals to 5.520 minus 4.908, which will be equals to 0.612 kilometer, which is equals to 6.12 meter when we convert it to meter. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the soft copy in bookshops, or if you are interested in the hard copy, you can get it at the website on the bottom of the screen. Thank you.